Alright, in this video we are going to learn section 2.4. This is the last clip for chapter 2. For this section we are going to look at some applications of Taylor series, and hopefully after you see this example you will appreciate Taylor series more. Alright, start from example 6. So example 6 is the application related to limits. So suppose that we have the Maclaurin series for cosine x, right? This is the Maclaurin series of cosine x. So basically it is the Taylor series of cosine x centered at 0 after you expand the first few terms, so you get the thing that I have here in the cloud. And then the main question is, well, we want to compute limit of x squared plus 2 cosine x minus 2 over 3 times x to the 4th power. So this is the one that we want to compute the limit when x go to 0. So you can see that if you are expert in Cal 1, you just want to use the L'Hopital rule, right? Because once you plug in 0 into the function, you get 0 over 0, and this is indeterminate form. Well, yes, you can use the L'Hopital rule, but it will take you some time to do it because you have to do it 4 times. Because you have x to the 4th power on the bottom, and then, well, that means you have to differentiate 4 times, right? Another way to do this thing is using the Taylor series centered at 0. So we're gonna show you how to do it here. So let's do it. Well, we're gonna start by saying that limit of x squared plus 2 cosine x minus 2 over 3 times x to the 4th power where x go to 0. Alright, this thing is what? So this thing is limit of x squared plus 2 times, well, I am going to replace my cosine x by this series. So I have 1 minus x squared over 2 plus x to the 4th power over 24 minus x to the 6th power over 720 plus dot 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 dot, and then minus 2, and then over 3 times x to the 4th power where x go to 0. And then after that, let's expand this thing. So we're gonna have limit of x squared plus 2, right, minus x squared plus x squared, x to the 4th power over 12, and then minus x to the 6th power over 360, and then plus dot 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 minus 2. Alright, and then over 3 times x to the 4th power. You can see that I just expand 2 inside the parentheses, right? And then after that, well, you can see some cancellation because your 2 here gonna cancel with negative 2 here. And then, well, your x squared here gonna cancel with x squared here as well. So now at the end you have limit of x to the 4th power over 12 minus x to the 6th power over 360, and then plus dot dot dot, and this thing over 3 times x to the 4th power when x go to 0. And then after that, if you simplify again, so you're gonna get, well, I just pull out 1/3 first, so 1/3 times limit of and then I just group x to the 4th power together, so I will have limit of 1 over 12 minus x squared over 360 and so on, where x go to 0. And you can see that the term here that I do the parenthesis in green, this thing gonna goes to 0, right? because it contains x in there and we take limit when x go to 0. So the second term and so on, there will be 0 eventually when x close to 0. So at the end, you're gonna have only 1/3 times 1/12, which is going to be 1/36. This is your limit. This is how we use the Taylor series to help you to compute limits. So now let's move to example 2. Alright, the next application is dealing with integration. So sometimes when you see the term that are impossible to integrate, you can just approximate it by using Taylor series. So example 7, suppose that you want to compute the integral of e to the negative x squared dx starting from 0 to 1. How do you compute this thing? So for sure, this is impossible to compute by using integration technique in Cal 1 because, well, that's no way to integrate e to the negative x squared. Even you try to do a substitution or by part or anything, impossible. So we're gonna switch the way and we're gonna just using the approximation. So let's see how it works. So we're gonna start by looking at the Maclaurin series for e to the x, and then the Maclaurin series or Taylor series for e to the x is given here. Well, the thing is that we're gonna use the first 3 terms to approximate this integral. So first of all, from the term that we have e to the x here, you can replace x by negative x squared. This thing gonna be e to the negative x squared equal to 1 plus. So I replace x by negative x squared. And then plus, I replace x by negative x squared. I replace x by negative x squared. So I keep going. And so on. Alright, so this is e to the negative x squared. And questions say that, well, let's use only the first 3 non-zero terms to approximate this thing. So it means we will use just only e to the negative x squared. This is approximate by 1 minus x squared and then plus x to the 4th power over 2, right? Because we cut only the first 3 terms. Here the first term, here is the second term, and here is the third term. So we just pick up the first 3 terms, and then now when we integrate this thing from 0 to 1, integrate from 0 to 1 e to the negative x squared dx, this thing gonna be integrate 1 minus x squared plus x to the 4th power over 2 the x from 0 to 1, right? And then you can just integrate easily now. Keep in mind that this is not the exact value, so this is an approximation, right? And then after that you can just integrate this thing. So I have integrate 1, I get x, integrate x squared, I get x cubed over 3, integrate x to the 4th power, so I get x to the 5th power, and then the denominator here gonna be 10. All right, and then I replace x equal by, just evaluate from x equal to 1 minus evaluate at x equal to 0. All right, so we almost done. And then at the end we have 1 minus 1/3 plus 1/10. All right, compute this thing. So that's mean I have 30 over 30 minus 10 over 30 and then plus 1 over 3 over 30, sorry. All right, that looks good. So I have at the end 23 over 30. Well, this is an approximation of this integral by using the second order Taylor polynomial for e to the x. Alright, let's do one more. Example 8. So suppose that I have the Taylor series for cosine x as I state below. Well, I need to compute integral of 1 minus cosine x over x dx x from 0 to 1. And also we're going to use the first use the first three terms again. Alright, so let's cut the first three terms first. So it's going to be this, right? 1 minus x squared over 2 plus x to the fourth power over 24. So this is your approximation. So cosine x can be approximated by 1 minus x squared over 2 plus x to the fourth power over 24. Alright, and then now when I compute integral from 0 to 1 of 1 minus cosine x over x dx. So I need integrate 0 to 1 1 minus x squared over 2 plus x to the fourth power over 24, and then over x dx, and then something cancel. So I have integrate 0 to 1 x squared over 2 minus x to the fourth power over 24 because this thing cancel, and then on the denominator I still have x here. So I can reduce my power by 1. So I have integrate 0 to 1 of x over 2 minus x cubed over 24 dx. And then now I have x squared over 4 minus x to the fourth power over 96. Right? And then because 24 times 4 is 96, and then evaluate at x equal to 1 minus x equal to 0. And then what I get at the end, I get a quarter minus 1 over 96. So the answer is 23 over 96. Alright. And that is the approximation for this integral. Alright, and that is the end of this chapter. So this chapter is short, so hope you can study this chapter in only 1 or 2 days, and then, well, you should be ready for exam 1 because exam 1 is coming up this Friday, and well, the content for exam 1 will be up to here, this page. Alright, so done with chapter 2.